Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through transformations of a parabola. So what are we actually doing here? Well, we're learning a method you can use to graph some but not all parabola. The drawback of this method is you can't use it on all parabola, but the good thing about this method is that when you can use it, it's quite easy. So what we do is we look at the graph of y equals x squared, which is kind of the standard, the simplest parabola, and we apply transformations to it. So hopefully you remember the graph of y equals x squared. We went through it last time. So this graph in blue is the graph of y equals x squared. We did it on a previous video in which we used a table of values. We don't want to use a table of values all the time because it does take a little while and isn't really that accurate for parabola. It's pretty good for linear functions, but not for parabolas. So this is what we went through last time. So what if I want to graph now y equals, say, x squared plus 3, right? So what we're doing is we're taking the x squared value and just adding 3 each time. So what will happen is the y value will increase by 3 each time. So if we look at this point here, the y value is 4. It'll move up to 7 in the graph y equals x squared plus 3. Here the y value is 1. It'll move up 3 to 4. And so on. So what you'll see is this black parabola is essentially the same as the blue parabola, except each point on the blue parabola is shifted up by 3. Okay? Each time the point has gone up 3, up 3, up 3. They're the same shape and same width and everything, notwithstanding my poor drawing. Okay, so that's a quick way to graph y equals x squared plus 3. What if we wanted to graph something like y equals x squared minus 4? Well, this time the y value will move down 4 because we're taking 4 away from the y value of this graph here. So the turning point and the y-intercept will be moved down 4, as will all of the points. And we have another parabola that is the same shape, same width and everything as the first two. All I've done is I've taken each point on the blue parabola and moved it down 4 because that's what's happening. The y value is decreasing by 4 to get from the blue to the yellow. So if I just graph this, again, sorry about my poor drawings, got parabola that looks like that. They are the same parabola, same shape. They're actually the same size, and you could put one on top of the other. If I move the yellow one up 4, it will fit perfectly on top of the blue one. If I move the blue one up 3, it will sit perfectly on top of the black one. So this is our first transformation. If I want to graph something like y equals x squared plus k, where k is a number, what it does is it takes y equals x squared and it shifts it up or down. It's a translation. So if k was greater than 0, as we saw in the black example, then it goes up. And if k is negative, then the parabola goes down. So that's an easy way. If I know how to graph y equals x squared, I can easily graph something like y equals x squared plus 3, x squared plus 7, x squared minus 9, or whatever. It'll be the same parabola, just shifted down 9. All right, let's look at another translation. So now I'm going to graph y equals, instead of putting the 3 out of the brackets, I'm going to put it in the brackets. Y equals x plus 3 squared. So this actually has the effect of translating y equals x squared. Instead of going up or down, it goes left or right. Because what's happening here is it's sort of making the points on the blue happen earlier. So you know that for y equals x squared, it goes through the point 0, 0, when x equals 0, right? But here, it won't hit the y-axis at 0 when x equals 0, because we've got this 3. X would be minus 3. Minus 3 plus 3 equals 0. And if you square it, you get 0, right? So this one wouldn't go through 0, 0. It would go through minus 3, 0. So it would go through this point there. But other than that, it's the same parabola. So what you can see is this blue one is going to get shifted to the left 3 units. And I can do that for that same logic for all the points. So this point here, which is 1, 1, I can shift it to the left 3 units. This point here, which is 2, 4, I can shift it to the left by 3 units. It'll go through there. The parabola will look exactly the same as the other parabola, but it's been shifted left. And note this point, which is 3, 9, it's shifted 3 spots to the left, okay? So that's our second sort of translation, our second transformation. If you have y equals... Oh, and this one I should point out is actually a little difficult because it sort of goes in the opposite way you'd expect it. So if I have y equals x plus h squared, as in I put the number in the brackets this time, it shifts y equals x squared left or right. So it goes the opposite way you'd expect it. So if h is positive, as we saw with the green, it actually goes to the left by h units. Okay, and then if h is negative, it actually goes to the right. It is sort of the opposite to what you would expect. So we've looked at 2 examples of translation. So what does it mean moves the parabola up or moves the parabola left? Well, a good way to think of it is that it moves the turning point left and right or up and down. So the turning point of y equals x squared is 0, 0. We went through that in a previous video. You can see it here. This is the turning point where the parabola stops and turns around. So if I have a function like this, where I replace x with x plus h, and I put that in the bracket, and then I add a number, remember this number moves it left or right, this number moves it up or down. So the turning point is going to be negative h is the x value, because this value moves it along the x-axis, left or right, and k is going to be the y value, because this value moves it up or down. So other than that, it's going to be the same parabola as y equals x squared. But this is a way that you could graph something in this form nice and easy. You just move the turning point. So let's have a look at an example. So I'm going to try and graph now y equals x minus 2 squared plus 3. So this minus 2 has shifted it 2 units. Again, it's the opposite way that you'd expect. It's actually to the right 2 units. And this number here has shifted it up 3 units. So the turning point of this will be 2, 3. Because remember, the turning point's negative h. So it's negative, negative 2, positive 2. So the turning point will now be here instead of what it was there. Other than that, it is exactly the same graph as y equals x squared. I just need to find another point. So I'm going to find the y-intercept. So the y-intercept occurs when x equals 0. So if x equals 0, you get y equals 0 minus 2 squared. So you get minus 2 squared plus 3, which is 7. Okay, so the y-intercept is 7. Other than this, it's just going to be the same as y equals x squared. So it's just going to be like this. Turning point, it's going to stop, turn around, and there you go. I have graphed that, and that did not take me long at all. Okay, so please pause and copy all this stuff down because I'm going to go through just one more type of transformation. So the last transformation we're going to look at is a dilation. So I've got the graph of y equals x squared here. So what if I wanted to graph the the curve y equals 2x squared? Okay, so that multiplies the y coordinate for 2. So it would still go through 0, 0. When x is 0, y would be 0. But if x is 1, y would be 2 times 1 squared, or 2. It multiplies the y coordinate by 2. So here the y coordinate was 4. It's now going to be multiplied by 2 and go to 8. Here the y coordinate was 1. It's multiplied by 2. Here the y coordinate was 4 and it is multiplied by 2. So the graph will look like this. Now it's still the same sort of shape, like a bowl kind of thing, but it's actually thinner. The parabola's gotten thinner. This number in front of x squared determines how thin or fat it is. And you can see that when the number's larger than 1, as it is here, then the parabola is thinner than y equals x squared. That's because it gets big quicker. So what if I wanted to graph y equals minus x squared? So that means it takes x squared, the y coordinate of the blue function, and it just makes it negative. So let's look at what that would be. I'll graph it in green. So it'd still go through 0, 0. So here for the blue, the y coordinate was 1. So it's now going to be minus 1. Here the y coordinate was 1. It's now going to be minus 1, and so on. Coordinate's going to go from minus 4 to 4. This transformation is a reflection. So the parabola is going to look like this. It's going to look exactly like the blue, except inverted, turned upside down. So when the number in front of x squared is negative, then it inverts the parabola. So that's our last transformation we need to go through. So if you have something like y equals ax squared, something times ax squared, if a is more than 1, it makes the parabola thinner, as we saw in the black one. If a is less than 1, so if a is like a half or something, it actually makes it fatter. So y equals a half x squared would look like this. So when you saw a is less than 1, as it is in the yellow, it's made the parabola fatter. But what's annoying about the thing in front of x squared, what makes it difficult, is it does two things. So not only does it make it thinner or fatter, it can make it inverted. So if a is greater than 0, if a is positive, as it is in the black, blue, and yellow one, then the parabola is a smiley face. It's the right way up. But if a is negative, it inverts it. So you can sort of see there are like 4 transformations that we've gone through. So the first 2 were both translations. They shift the parabola left and right, or up or down. The next one here was a dilation, and then the last one was a reflection. So they are the transformations you need to know. So I'm going to rub out all the graphs now and just do one more quick example. Have a look at graphing the function y equals minus 2, let's say x plus 1 squared minus 3. So we've got a few transformations to apply to it. We've moved it down 3, we've moved it 1 to the left. Remember, it goes in the opposite way that you'd expect. We've dilated it by 2, so we made it thinner, and then the minus means we've reflected it. So let's start with the turning point. So the turning point of this will be h, which in this, minus h, sorry, which in this case is minus 1, and then k, as I showed you in a previous example. So the turning point of the parabola is at minus 1, minus 3, which is this point here. So that is going to be the turning point. So we know that the parabola isn't going to go that way. It's not going to be a smiley face because here a is negative. It's going to be a frowny face. So it's going to look like this, okay? And it's going to be thin because of the minus 2 part. The 2 part makes it thinner than y equals x squared. So what we might do is find the y-intercept. So the y-intercept occurs when x equals 0. So when x equals 0, y will be minus 2 times x plus 1 squared minus 3. So this part here we do first because of the order of operations. It'll be minus 2 times 1 squared is 1, minus 3, which gives us minus 5. This will be the y-intercept here, okay? So we can graph it pretty quickly. It's going to look like y equals x squared, except it's going to be thinner, and it's had the transformations applied to it that I've just shown you. So this is a quick way to graph things that have had transformations applied to you. It doesn't really go through how to graph something like y equals 2x squared plus 5x plus 6. This is not one in the right form. that's just taken y equals x squared and had transformations applied to it. We can't use it for ones like that, but we will learn how to graph ones like this in a subsequent lesson. All right, sorry for the long video. This has been the luckiest maths teacher in the world. Have a great day.